Hi everybody, it's me Phil. I've got something really exciting to show you all today. This is ReMarket, my project for my big data analytics course from university. It is a social media marketplace application where you can both make purchases, add friends, and create posts all in the same application. Let me show you how it works. So to start, this tech stack that I've used is ExpoGo for the majority of the application when it comes to the front end. A lot of the back end stuff is handled through Firebase. Meaning my database is Firebase. I didn't use MongoDB or MySQL. This is using Firebase again, just like my capstone project uses. And on top of that, I use Python for the recommendation algorithms. I have utilized PySpark actually in order to create recommendation algorithms for all users. So I will delve into that in a second, but for now, here is what the home screen looks like. So on the home screen, it is based loosely off of Venmo. So as you can see, we have the bubbles of your friends at the top. You can scroll through here. You can click search and search for users. We search Nath. We get Nathan, my friend Nathan. As you can see his purchases, you can see his friends pretty easily. You can add him as a friend now that the request is pending. So let's go back to the home screen, and you can see my friends have made quite a few posts. So all these posts go from the order of most recent to oldest. You can scroll down all the way down, really, if you want. And posts update in real time. There's no swipe up to refresh. So you can go to the oldest post, Pig Chungus, and then Abracadabra UX style. You can leave a comment. You can like every post if you want. So there's that. Here's the shop. It's sorted in 3 different methods. There is recently posted. So this sorts all items in the marketplace from recent to oldest. It has up to 10 items in here. If you want to see more, you can click View All and view it in pages. Here's Viewed by Friends. So this is one of the aspects that the algorithm that I wrote in Python actually filters. So it basically ranks all items in the marketplace from things that you are most likely to buy based on what your friends have purchased, right? So that is what becomes index 0 in this really long array of recommended items. As you can see, user recommendations right now, actually that's what's shown in Safari. We can go down to this account. I think this account is, and it has the same user ID. Here it is, maybe. Oh, this is user recommendations. My bad. So here is friend recommendations, and it has the same ID as the user ID. I will go into the database a little bit more in a second. So we have the recently posted, viewed by friends, recommended for you, and viewed by friends or recommended for you, both handled using an algorithm created in Python that utilizes PySpark. We can sort by category, and this sorts by category most recent to oldest. Again, most recent to oldest posted. So we can search fashion, home, beauty. I haven't looked at the app in a while. And we can go to View All, and we can sort in the 3 different methods that you can on the main shop page. And each page contains 8 items, and then you can just use these arrows to go back and forth. There's also a shopping cart. So if I were to add something, scary masks, we add to the shopping cart, we can check out, we can leave a message. I can't wait for Halloween. I forget how to spell Halloween. I always do, but, well, hey, that's life. Well, check out, and it'll end up on my home screen. You do get to see and like and comment on your own posts. Anyway, I have this big search page. You can search for anything. You can search for items or users. So let's search Nathan Halash. We can search get Big Chungus. You can't buy your own items, but you can go to these pages. Anyway, so there's that. We can go back to search. Let's go to selling. This is where you can see all the items that you are selling. I'm selling a baseball cap. You can go to the listing, sorry. Click on Big Chungus. Samsung Galaxy S23, you got all this stuff. You can delete your listings if you want to. You see the quantity of the listing. And here's my profile. So if you don't have a profile connected, it will have a plus that says connect profile. or connect payment method, sorry. And from there you can add it from the settings. On this profile page, you have your friends list. This is sorted alphabetically. So you can just scroll through here. I have a lot of friends. Look at that. And you can look at purchases. These are sorted most recent to oldest. You can go all the way to the bottom. My first book, the first thing I bought is this UX Magic book. So that's pretty fun. So here's the settings. Just to show you all, you can change your account details, your name, your username, your email, your picture. You can change and add payment methods. So that's what that looks like. You can edit payment methods. Same thing for shipping addresses. You can change your password if you feel like it, and you can log out. Here's the notifications page. So basically every time you get a notification, this bell icon has a red dot under it, and from there you can swipe and then delete if you want to. So pretty cool. I should note that I'm using Swipeable, which is a deprecated library for these notifications, but man, it works so well. It works so well. It was fantastic. So yeah, now that I've covered this a little bit, I mean, I could just show you profile. Here's my other profile. You can see the activity, and you can see all my friends on my other account. See, a lot of friends. Anywho, now I would like to show you all the layout for the database. So this is a lot cleaner than my capstone project. This is probably the cleanest I've ever had a database. So you have this users collection, right? Because that's how Firebase works, collections. So inside this users collection, you have all these sub collections, right? You have friends, listings, notifications, payment methods, purchases, shipping addresses. That's where I store all the user information. The only things I have in the user are the avatar, which I will need to start changing this to be local storage, but I'll show you that in a second too. The user's cart is added as an array, so if I were to just add something to my cart, it will update in the database. See that? Isn't that cool? And then if I take it out of the cart, it's out of the array. Email, first name, last name, username. So that's pretty cool. Sub collections are friends. So these are all the friends that you have just throughout the app, and it just has their ID. So that's what's used to fill this homepage. It looks for the ID, and then from there it goes to their user page. Not the most secure, but I only had around 3 weeks to develop this application, so I just worked quickly. And this is my first time doing anything social media related. Also, I am working on another social media application. I'll decide if I want to like show it off or not. I think I will though. So stay tuned for that. So I'm pretty excited for that. The user's listings. It's good to note that every time a user actually makes a listing, it's not just added to this user's personal listing page. It's added to this marketplace page, which has every item with its details, and it has a way of linking back to the seller's listing. So that way, when the seller deletes the post, it deletes in the marketplace, so it doesn't show up in the shop page for everybody. So essentially, listings in the friends, the listings collection and the friends collection is what shows up for selling, and the marketplace collection is what shows on the shop page. That way, everybody can view it, and it's much more easy to manage. So notifications, that's what happens when you have this notification bell. All these notifications are stored, if we go here, in notifications. So, the type of purchase is what determines the text that shows, right? It will say bot in the message. Like, there are only so many types of notifications that you can send. So it identifies that type of notification and then sends a text message and fills in the information accordingly. We have payment methods, which is what I just showed you, purchases, which is what shows up under my profile for here. And when people search your profile, it goes to your purchases, and it will show your purchases to that user. Shipping addresses, what we just went over. So that's what that looks like. So this is the layout of users. So if we go to friend requests, so this is how I handle social media. Every time you send a friend request, it has a status either accepted or pending. And if the user declines it, the friend request just gets deleted. There's no declined status, it's just pending. So this is the one I just made, sender ID, that's my account, receiver ID is Nathan. So, yeah, and it has the time as well. that's useful for the notifications. And I guess I should cover, so Marketplace, like I said, when you create a listing here, you can upload an image. Anyway, when you create a listing, it creates it both in the user's listing and in Marketplace. So Marketplace is where everyone can see the shop. Listing is where you can see it for selling. Anyway, so let me show you all how I developed these recommendations, because these recommendations were the big data part of the big data analytics project, right? So we use PySpark. So PySpark is a tool that developers use to analyze and perform algorithms on large amounts of data. So they use these things called RDDs. They analyze RDDs. They perform their operations on RDDs. It works almost as like a functional programming language. The way that you perform actions and transformations on these RDDs. So anyway, let me just show you how I did it. Because using PySpark on a database that's through Firebase and through a tech stack that's entirely JavaScript was not easy. It was not conventional, and it took a lot of trial and error to get it correct. It took a lot longer. Yeah, I mean, I spent a whole 12-hour day on it. It was very difficult to think about. So let me show you the code. Let me show you the algorithm and try to walk you through what I did here. So let me cd / spark jobs. Okay. Here's we call it recommendation API.py. And all this code, by the way, is available on my website, philipsolis.com. It's under the project section. You can click the GitHub little bubble and it will show up. Anyway, I digress. Here is what the recommendation API looks like. So we used PySpark. Let me move my face just for a second. No. Okay, move my face so you can see my imports. So we have from PySpark.sql import Spark session. So Spark, we import the, basically these are ways that we can adequately, how do I put it, translate our Firebase NoSQL schema into a SQL schema, into a relational database of some sort with primary keys, and the primary key being the ID of each file in Firebase, each item in Firebase. So we import row, column, struct type. So the struct type is what we're going to use to just explicitly define our schema. And I will show you all that in a second. Firebase admin is how we are able to actually run any sort of algorithm on our Firebase database in Python. Now, this is important to note that we can only use Python with our database. We can't use it within the application. We can't make calls to this API from the application. Ideally, if you were to open the shop page, that's when you would want this algorithm to run. However, with the limitations provided by Firebase currently, it's just not possible. Another limitation from Firebase is that all queries for now have to be caps sensitive. So if I research failed graduation with a capital B, I lied. Okay, that worked. Hang on. Let me try to search. Yeah, so if I search for Big Chungus, right, and I use a lowercase b, it just doesn't know what to search for. It won't search for Big Chungus like if I did this. Okay. It is not cooperating. Hang on. I just want to give an example. So see how that shows up with nothing? Now we do this. Okay. I thought I was going to be proven wrong. Okay. But no. So it is cap sensitive for now. That's just how queries work in Firebase for the time being. I was really worried. But big chunk is big. Isn't that crazy? Anywho, let's get back into it. So you all can see I import Firebase admin credentials parser. So credentials come from this service account key. Nice try. You're not getting it. This is what I use to run the code off of Firebase. We use the paid plan for Firebase. I think it's called Blaze. Anyway, it's not very expensive to run. It's maybe like $1 or $2 a month. Nothing crazy. Anywho, we create references to each of these collections so that we can use it, right? So user ref is our collection of users, marketplace ref, marketplace, and basically everything we're going to be modifying, right? So we have all this data that we collect, and we're fetching the user. So basically, it's help. I guess I should note before I get too far into it that the parameter for running this script is just a user ID. So it takes the user ID and now it's grabbing all of the user and purchase data. So it grabs the purchase data from this database. Let's get this working here. So it will grab the user data. So if we go here, it will grab your friends. It grabs your purchases, right? Because that's how we run the algorithm. So that's exactly what we're doing here. We are defining the terms that come from the user collection, user ID, and for purchases, item ID, image URL, item name, all the things that I have shown you that exist in the database currently. So here we're fetching marketplace data, and here's where we just explicitly define our schema. And this is what I meant by using struct types. This is how we're going to be able to actually manipulate our data. This is how we're going to be able to run any sort of algorithms on our data in our Firestore database. Is using these struct types. We are taking each item, each attribute of purchases. We are telling the program this is what we are looking for, and same with the user schema and the marketplace schema, or else you won't be able to actually use this information. So from here we create a data frame, and here is the actual algorithm. Well, okay, I should elaborate. So this is part of an algorithm. Of our, down here we have this recommend items hybrid. This is what we ended up using for our recommended for you recommendations. So we have, let me just go through the code. So we have recommend items based on purchases. So this ranks items based solely on what the user buys by category. So if the user buys more of one category, it's going to recommend the items of that category first, and then after that it will recommend items from the next category, etc. So it's pretty simple here. We just use Spark. It was a class requirement that we use PySpark. So we used PySpark to do it. We started by using this lambda function to make everything lowercase. It makes it easier. And we did this for everything. It makes it a lot easier for comparison purposes. So that we can match the purchased items with their marketplace items, like what we do here. Because again, every time a listing is created, it's put both in the user sub-collection of purchases, like if it's bought, it's in the user sub-collection of purchases, and it's also in the marketplace. So that's how we get the data for both of them, because we need a way to direct the user to the marketplace item from another user's purchases. So here is the actual recommendation item, recommendation algorithm at play. So we have to ensure that the user has not purchased the item before we recommend it, obviously, and then we just filter based on what category the user has purchased from. We check the user's purchases, those categories, and then we filter based on those categories. So items bought by friends, this is even more simple. We just take literally the amount of times an item has been bought by a friend, and that's what puts it at index 0. If it is the most bought item by friends, it is at index 0, then index 1, then index 2, etc. Like it just goes in order of the amount of times it's been bought by your friends. So that's what this whole algorithm is doing. It grabs the friends' purchases, we also filter out the items sold by the user. Important to know so that your own items don't get put in any of these recommendation algorithms. Yeah, so we run the marketplace with the friends' purchases. That's how we are able to rank our items, and so that they show up as marketplace items and not as your friends' purchased items. That way you can actually interact with it and buy it, and it goes in the marketplace. And the program works as expected. Right, so here we have the hybrid algorithm. So this is what is used for recommended for you. It combines that recommended for you algorithm that I have already shown you with the items bought by friends algorithm that I have just shown you into basically one ranking. It takes the items both that the user has purchased from the categories the user has purchased from, and the items that the user's friends have purchased, and kind of combines them. It literally combines them. It joins them. Now these distinct is something that will be really helpful here, because you want to make sure that everything is that the same item doesn't show twice. An issue that we had for a long time was that items that were both viewed by friends and recommended for you, like in each of the separate algorithms, would both show up in this ranked system, and they just show up right next to each other, and then you'd have multiple of the same item, and you don't want that. So we had to be careful with our lambda functions. But yeah, we get from. I mean, that's how this hybrid recommendation works. I can show you the main. Or here's how we write recommendations to Firestore. So we create this collection recommended items, friends recommendations, user recommendations. That is what gets. Let me go back to the database just to show you all. I apologize. This is taking a long time. I'm trying to make sure I cover everything here. So now we can go to user recommendations, friend recommendations. So this is where they end up, and that's where that comes from. Snapple. Let me see this. Okay, it comes from here. Write recommendations to Firestore, and then into these collections. And then we have our main, which is just running it on the user ID. You could make this run on every user ID, which is what I did for demonstration purposes originally when I presented it, but it runs much quicker if it's just one user ID, so I just did it on one user ID. Another limitation of this program is it takes a long time to run on computers with less than 16 gigabytes of RAM. My friend tried running the algorithm on his computer, and it took like 4 minutes, and that's not going to be the case here. I'll show you. I have a MacBook Pro with an M2 Pro and 16 gigabytes of RAM. So let me show you all. Okay, I guess I don't have that. Python 3, recommendation API.py, and then let me go back here and grab the user ID of the user I want to see, and then let's go to and move. OBS is crazy. So let me move myself back over here. Hi everybody, and we can go to run this algorithm like so. So we have Python 3, recommendation API.py, and then the user ID that we want to edit, and that's our user ID. So notice this is about to all change. Viewed by friends, recommended for you. So we are going to press enter. And it's going to take its sweet time. And it gives console output for everything, just for troubleshooting purposes. And as you can see, everything just changed in real time. All the viewed by friends, all the recommended for you stuff is now completely different. Yeah, so I mean that's my recommendation algorithm in PySpark. And yeah, I mean I guess that is as ReMarket 2.0. If you want to try it, feel free. And it's pretty easy to register using email, password. It doesn't even have to be like a real email. You can just do a fake email if you're uncomfortable. And I don't see your password. So don't ask me if you forget it. I won't know. I'd have to delete your account and you have to recreate it. It's handled through Google. It's not stored in the database. I don't know if you noticed that. But yeah, no, that's ReMarket for you. That's the application. I'm really proud of it. It was hard, I mean, it was Obviously I'm familiar with Expo. I'm familiar with Firebase because of my Capstone application, but I was not familiar with PySpark. I was not familiar with using Python with Firebase in general. Um, the documentation's a little scarce, or sorry, help is a little scarce on the internet, but I got through it, and the source code is on GitHub. So if any of you want to take a look at it, any of you want to, use this application, I have a web version of the application that you can use, and it works just the same. Feel free. But yeah, other than that, that's the end of this video. Thank you all for watching, and I'm really excited to show you all what I come up with next. Goodbye.